Hi everyone! In this lesson we'll talk about materials and textures. The created 3D models initially look quite simple and can only differ in color. Without materials, they look gray and flat. To make them look the way we are used to seeing them in real life, we must assign a material to each object and specify its physical properties: color, roughness, transparency, strength of reflections and refractions, and so on. The Materials panel is here. This is Material Manager. Here we can see all the materials we created. To assign a material, we can drag and drop it onto an object in the viewport, like this. You can also drag and drop it onto an object in the Object Manager. The Material tag appears on the object. In it, we can choose different types of projections. Usually, we select the standard UVW mapping, that is, projection by texture coordinates. But you can play with different types of projections. The tag also has very useful tile and offset parameters. Tile allows you to make the texture smaller or stretch it, like this. Accordingly, you can see that the number of repetitions of the texture has increased. This way we can adjust its size. The offset parameter allows you to offset the texture vertically or horizontally. We can also assign material not to the entire object, but only to selected polygons. To do this, select the polygons and drag and drop the material onto them. Now let's create a material. Go to Create, Redshift, Materials. To open it, you need to double-click on it. We see the Material Editor menu. Here, the node system is used, which means that each node has an input and output. And thus, connecting the nodes, we transfer information and enable certain properties. The most important node is the Material node. We can add other nodes by typing the name of the node into the search or selecting it from the list. Select the node and drag it. Let's take a closer look at the Material node. There are ready-made presets that you can use. They are often enough to get you started. Here we have metal presets. Here you can see what the material looks like. The glass preset looks like this. We also have plastic as well as different liquids. For example, water and milk coffee. Let's take these presets as an example and figure out how to create and edit various materials. To get started, note that all materials are divided into conductors, metals, and dielectrics: water, glass, wood, plastic, and so on. This is important to get a realistic result, since the reflections of dielectrics is always white. For example, I will choose the plastic preset. We can see that the color of the reflection is white, but the glare on metals is always painted metal colored. For example, I will choose the gold preset. In this case, the glare is golden. In the future, we will go back to the distinction between metals and dielectrics. Now let's talk about it in more detail. Let's start with the plastic. I create a material. I will demonstrate this using a special model. This is the shader ball. The geometry of this model well illustrates all the features of the material. In the material, select the plastic preset. When working on plastic materials, we usually edit a small number of parameters. First, this is the diffuse color. That is the color of the material. Here we can select or paste a color code. Next, the weight parameter. It is responsible for the weight of the color. The next parameter is color roughness. We leave it at 0 for perfectly smooth materials. You can set it to 1 if you create dirty or matte plastic. Remember that this setting will only affect color characteristics. Next, we need the reflection roughness parameter. If it is set to 0, we will get a glossy surface as it is now. If we set it to 1, it will become matte. Fully matte plastic is extremely rare. The usual value for matte plastic is in the range of 0.5 to 0.8. And that's pretty much all the parameters we usually tweak to create plastic. This is one of the simplest materials. Looks straightforward, doesn't it? Plastics are often used. For example, in the 2D to 3D video, they were used to create the hand, gamepad, and many other objects. Now the next simple preset is paper. The diffuse color parameter is used here, as well as a new parameter, backlighting translucency. It gives the effect of translucency of thin material in the light. Try to hold a piece of paper up to the light and see how it shines through. This is exactly what we want to get. You can choose the color and also its strength. For example, for leaves, this color can be light green. We use this parameter when we have one-sided geometry, napkin, sheet of paper, or a thin leaf of a plant. Here we also need the reflection parameter. We'll cover reflections and refractions. Let's first talk about a ray. It can be absorbed, reflected, or refracted. Here you can see a diagram of how rays work. When we see something green, it means that a wave with a length corresponding to green reflected from the surface and hit our retina. We have the diffuse parameter, in which we just set the color. Reflection is the ability of a ray of light to be partially or completely reflected. When a ray is reflected at the same angle that it entered, we consider such a surface to be specular. When it is reflected from different angles, we see that the surface is rough. This parameter is called roughness. Pay attention to the Fresnel type setting, which is in IOR mode. This item allows you to adjust the reflection. There are several types here. We're interested in color plus edge tint and IOR. Color plus edge tint is more commonly used for metals and IOR for dielectrics. I will explain to you what it is. As I said in the beginning, it is important for us to know the strength and color of the reflection so that the material looks realistic. For dielectrics, it is white. And the IOR, or index of refraction, it will be in range from 1 to 2. If it is equal to 1, then there is no refraction, and we get a completely matte object, as in the paper preset. Typically, the default for dielectrics is 1.5. And you can use that value. It is suitable for plastics, wood, and many other materials. Use 1 to create a completely matte object, just like with paper. You can play with this parameter to see how the material changes. Refraction is also important. Refraction is the ability of a ray to change direction when it passes through some substance. Remember what your body looks like in water. It looks like that because of refraction. It is extremely important for water, glass, lenses, and so on. Paper now has an IOR of 1, which means there is no refraction. In this case, the rays of light will not change their trajectory at all when passing through such a material. Let's select a water preset and see its index of refraction. IOR of water is 1.33 and 1.51 for glass. How to find out this index? You can find it in the tables which are freely available on the internet. Next, we need to pay attention to the samples parameter. This is the number of rays emitted per pixel. Increase it if you get a noisy result. But in this case, the render time will also increase. When we work with metals, aluminum in my case, the most important thing is to adjust the color of reflections. That is the reflectivity parameter. For metals, the Fresnel type should be color plus edge tint. The BRDF parameter must be in GGX mode. Pay attention to diffuse. The weight parameter must be equal to 0. You only need to control two parameters, reflectivity and metal edge tint. Metal edge tint should be slightly less saturated than the shade selected in reflectivity. For simplicity, you can use the existing presets. They are very convenient. Let's also mention sheen. It is primarily intended for fabrics. It is needed to create the effect of backscattering. It is soft light scattering, which we are used to seeing on velvet-type fabrics. Let's see what the material looks like without this parameter. And this is how it looks with weight set to 1. Here you can see an example of a material without using sheen and with this effect. Now let's cover transparent materials. There is a glass preset in the list that we use a lot. To create matte glass, the roughness should be increased. So the glass will have a roughness. The refraction weight parameter is now responsible for the transparency of the glass. If you reduce it to 0, the material will no longer be transparent. Also note that the glass has no diffuse. Now let's look at an example of how to create a diamond out of glass. To create this diamond for a 2D to 3D movie, we needed to set the dispersion in the shader. Dispersion is the physical phenomenon of the decomposition of white light into a spectrum because of interaction with matter. You could observe the dispersion of light in water, diamonds, and in a rainbow. Look at the dispersion parameter and you can see that it's set to 3. When we decrease it to 0, dispersion disappears. There is also an interesting thin-walled checkbox here. Tick it if you want to make the material so thin and transparent that it won't refract. It can be a soap bubble. Now let's talk about subsurface scattering, or SSS. This effect is observed in all organic materials. It is especially noticeable in liquids, for example juice, and is also present in all fruits and leaves. Without this effect, they will look plastic. But SSS is not only observed in organics, and some inorganic materials can also have it. For example, glass, some types of plastic, silicone, paraffin wax, and so on. This effect can be observed when the light rays do not pass through the object but are scattered inside it in different directions. So we cannot see through the object, but we see the light inside it. For us, it looks as if the object is translucent. Why should we strive to use SSS? Look at this strawberry with and without SSS. The strawberry on the left looks plastic. Redshift, for example, has several tools to simulate it. That is, single scattering. This is the group of parameters. And there's also multi-scattering. Here's the multi-SSS tab. For semi-transparent objects, we use single. And in case of opaque objects, we use multi. I want to show this cherry as an example. They are the same model, but with different materials. The first one is a cocktail cherry. It looks a bit like jelly and becomes translucent when soaked in syrup. Otherwise, it will be an ordinary cherry. Let's take a look at the materials. If you are configuring single scattering, then your diffuse weight should be 0. Usually in single scattering, I only configure 3 parameters. We can choose extinction or transmittance mode. The transmittance mode is used when subsurface scattering is not pronounced. For example, in tinted glass. Extinction is used more often and is suitable for liquids and jellies. For example, I will choose a preset coffee. In the coefficient, we need to specify the color. This is the color that will be absorbed. How does it work? As you can see, the color I have is blue and the cherry is red. You need to open the color wheel and select the color that is on the opposite side of the desired one. That is, if blue is required, in this paragraph you should select and adjust yellow. Next is the extinction scale parameter. Usually here we work with very small numbers. The higher the value, the denser the material will be. The next parameter is the color of the scattering. You can leave it white or play with it. The scatter scale parameter shows how far the rays enter the interior of the object. The larger this parameter, the lighter and cloudier the material will turn out. Now let's talk about multi-SSS. The objects for which we use multi-SSS have a dense structure and their own color. For example, this cherry on the right. So we select a diffuse color for them and increase the diffuse weight. Multi-SSS is typical for fresh fruits and vegetables, as well as thick sauces and substances such as cheese. Here you can specify several different scattering layers, but we will just need to turn it on and adjust the scale. To do this, you need to set the value of the amount parameter and adjust the radius scale. Also, here you can specify the color of the subsurface scattering. Remember that SSS is highly dependent on the size of your item. If, for example, the orange you are creating does not correspond to its real size and is many times larger, SSS will also require large numbers, and vice versa. To fine-tune the SSS, position a large area light behind the subject and turn off all other sources. And also make the material matte. Then play with the parameters until you achieve the desired result. So where did I use the multi-SSS in the video? In many materials: cheese on pizza, hot dog sauce, pear, and so on. It is important to mention that Redshift has powerful presets that cover almost all the needs a beginner can have. There's glass, water, tinted glass, and milky coffee with a single SSS example. We also have a ready-made skin preset. It's in the skin list of materials. Based on it, we can customize the material for our tasks. I also want to show you a few other materials. In Redshift, you can create and customize a self-luminous material. To do this, we need to go to Create, Redshift, Materials, and select Incandescent. Also, any material has an emission option. It is in the Overall tab. Here you need to specify the color and adjust the strength of the glow. Now let's talk about textures. You cannot put textures on objects until they are unwrapped. Unfolding transfers volumetric shapes to a plane so that textures can be placed on them. Let's go to Layout, BPUV Edit. For the unwrap and textures, we have a 1x1 square. The UV must fit into this square. It is desirable to fill this square as tightly as possible. Previously, we had to create an unwrap manually, but with the Cinema R22 version, we can create an automatic unwrap. There are 3 different ways to automatically unfold the geometry, and you can try some of them. Next, I'll show you how it works. Most importantly, you will not be able to unfold an object until you have converted it to geometry. To convert it to geometry, press C. If you download a tiling texture, that is, a texture that repeats seamlessly, then automatic unwrapping will suffice. The tiling texture looks like this. In my case, I needed to apply this bun texture to the model. It is flat and not tiled. First, I need to cut it so that the texture fits well and doesn't stretch. Stretches are places with an uneven UV mesh, which means that the texture will either stretch or shrink, and it will be very noticeable. Let me show you how unwrap the hot dog. First, let's remove this UV tag that stores the unwrapping information. Remember that UV can only be created for geometry. That is, you need to convert an object to geometry by pressing C, or by choosing Current State to Object. In my case, this object has already been converted to geometry. Now I will select the Set UV from Projection option so that the UV tag is created on it. Cool. Let's open the texture. In the File window, select New Texture. In my case, it is already open, so I will select it here. Since my hot dog bun is stylized, I choose the part of the texture where there is less bump. That is, there is less relief and a smoother surface. Thus, our future UV will have to be in this area. I can try to unwrap it automatically so you can see how it's done. To do this, go to Polygon mode and select everything by pressing U+W. Now in one of the auto UV modes, I will click Apply. So you can see that Cinema has divided the entire mesh of the object into several pieces, UV islands. In this case, the automatic unwrapping is not very suitable, but you can work with that too. In most cases, doing it automatically is enough for you. Now I will show you how to cut it manually. But first, put all the pieces back together. Go to the Projection tab and select Shrink. Now we need to make a cut. To do this, I will go to Standard mode and select Edge mode. I need to select those edges along which I will cut. These will be future seams. That is, the joints of the texture. I want these seams not to be visible in the frame, so I will cut in the place that is hidden by the sausage, and another seam will go down the middle along the back of the hot dog. Press U+L to select Loop Selection and select this loop. If you accidentally select something wrong, you can deselect it by control-clicking. Hold down Shift and select another edge loop here. Now choose Select, Set Selection. The object now has a tag that stores information about these selected edges. Now switch to BPUV edit mode. We need to select Relax UV. Here, select the Cut Selected Edges and Use Tag options and drag our selection tag into this field. Select the Auto Realign option. Now in ABF or LSCM mode, click Apply. We got these UV islands. I will switch to the polygon editing mode and select each of them using the U plus W combination. Let's see where it is on the model. Let's also check if they are oriented correctly. This is very important because otherwise you may not get the results you expected. For example, a mirrored label, and so on. For this, we have a UV map mode found in the Textures menu. It lets you know if the UV islands are upside down and position them correctly. To place UV islands in coordinates, we have the UV Transform tool. It allows you to move, rotate, and scale. It is important for us that the UV islands are of comparable size to each other. Let's open the texture again. As you can see, these parts need to be positioned here. Let's move the first one to the right place. Now select the Magnet tool and edit the mesh so that its edges match the texture. Just don't place it too close to the edges. It is better to place it in the center as the edges have some shading. Do not try to take care of the mesh inside. To align it, we have a life hack. Now we will do the following. Click Pin Border Points and remove the rest of the checkboxes. Now click Apply and the mesh inside will be smoothed out. Now let's repeat this for the rest of the UV islands. In this tool, we can edit the radius of influence, which is very convenient. Another useful tool that I would like to show you is the distortion option in a view menu. It demonstrates where the mesh is compressed and where it is stretched, which is important when we apply textures. Places where the mesh density is too high are marked in red. The texture in them will be small. And in these blue places, on the contrary, it will stretch. Now we just have to assemble the shader. Don't be afraid, it's not difficult at all. Create a new Redshift material. We need textures. Drag this texture to the Node Editor window. Pull on the right edge to connect it to the material node. We need to connect it to the diffuse color channel. Let's now assign this material to the hot dog geometry by simply dragging and dropping it in the viewport or the object manager. Almost ready. However, now it is too shiny. Let's change it in reflection roughness. Let's set the value to about 0.5. You can also make a bump map for this texture. That is a bump. In the search bar, find the bump map node. Connect it to the input port. From the output port, go to Overall, Bump Input. I have two versions of this texture. One of them is more realistic. I styled the other in Photoshop, blurred it out so that there are fewer small details. Now I'll show you how to connect textures downloaded from textures.com. Let's make a wood material. Usually, you only need 3 texture maps: diffuse or albedo, roughness, and a bump map, height or bump. But I will also show you how to include ambient occlusion maps, or AO, displacement, normal, and metallic. Let's create a new material. Open up Shader Graph. I downloaded a few maps and dragged them into the Node Editor window. The first one I always include is the diffuse map, or albedo in this case. Then roughness. Go to Reflection, Roughness. The next AO, or ambient occlusion map, is the shading map. There are several ways to connect it, and the easiest one is to multiply it by the diffuse map. Select the Adjust Color Multiplier option in a diffuse map. It will visually make the color more interesting and deeper. The next is a normal map, where the micro-relief information is stored. The best way to connect it is to create a normal map node, and then select the normal map in the path field. The texture node can be deleted. Now let's connect the normal map to the overall bump input channel. Let's assign the material to the shader ball. We got a beautiful wood, but it is slightly different from the desired material. It is shinier. This is because Redshift did not accurately interpret the color space in which the roughness map resides. Let's go into it, and in the color space field, we will indicate, instead of auto, raw. It is suitable for black and white maps. Let's take a look at the result. Super, we got the desired result. The wood became less shiny. Now let's look at how to work with a displacement or height map. For this, I will use this material. We can connect the height map to both bump and displacement. The difference is that bump does not affect geometry, unlike displacement. I will transfer the textures and connect them according to the scheme. First diffuse, then AO, then roughness, normal map. The last thing we need to do is include displacement. Create a displacement map and connect a texture to it, to the text map channel. Then connect the displacement in output displacement. The most important thing is to assign the redshift object tag to the geometry, in which you must include the following options. Geometry tab, enable the override parameter checkbox, as well as the tessellation and displacement parameters. Drag the material onto the shader ball and look at it. Now the displacement is very pronounced. Reduce it. I'll set the displacement scale to 0.5. Let's see what happens. The result still does not suit me. I will decrease it more, to 0.1. Great, now it looks more natural. This is how you influence the displacement in the material. And the last one is the metallic map. I suggest connecting in the following way. Using the Material Blender node and mixing the two materials. For this, I will create another new material. I'll transfer the maps here. Copy the material node, just select it and control drag it. We will include diffuse and AO in one material. We will connect the remaining maps to both material nodes. We'll also connect the displacement. Now select the metal in the second material node. Create a Material Blender node. Connect the first material to it as base color, and metal as layer color 1. Specify a metallic map as a mask for mixing the two materials. Namely, connect to blend color 1. Let's assign this material and take a look at it. We can play a little with the displacement scale value. Excellent. Material is ready. We've created some interesting materials using textures. Now you know that making beautiful materials is very easy. Experiment with them and have fun. And be sure to do your homework. I promise it will be interesting. See ya!